Hello, this is an introduction to strings in Java. So I'm going to go through what strings are. So this is for absolute beginners in Java. So I'm going to go through what a string is and how to create strings, the common methods for strings, how we can add strings together to create new strings, how we can compare strings, something called Immutable about strings, something about the string pool, how to split and join strings, looking into strings and how we can loop over strings, and lastly, how to convert strings into other data types, which we often need. For the purpose of this video, I'm going to create a new project in IntelliJ IDEA, and I'm just going to make a console project. So I'm not going to create any user interface for this because we're working directly with strings. So first off, I'll create a new project, and normally I create these JavaFX projects, but here I'll go for a normal Java project. Strings tutorial, let's call it that. Maybe strings beginners. And I'm just going to leave everything as is. It's important I add the sample code to make an easier start simply. I choose Liberica full here. You can choose any JDK for this. You don't need Liberica only if you work with JavaFX, the Liberica full. Others will be fine, OpenJDK, whatever. So let's try to create the project and get started on that. So now we have the project up and going. Some stuff is coming up here with Microsoft Defender. I told it to do that automatically many times, so probably just going to go away by itself. So let's see. So what do we have now? We have one method in here, like a main method, and it has some breakpoints and stuff set. So I'll just click this red one to remove that and remove these code snippets here. That's pretty annoying. So I'll remove that just pressing delete. So this is, I'll also remove this loop so we get back to something like this. So what this does is it prints out something to the screen. So we can see we can just use print, it says, instead of printf. So let's try to do that. So print. So if I do this, it will print out whatever it says here, like hello and welcome. And we should see that in a console. So it's a text, pure text application. It will take a bit of time, especially the first time for running it, and then it should, okay, so it says hello and welcome. So already we can see that it prints something to the screen, and what it prints is what's called a string. So this is a string. Let me just zoom in a bit. So now it's a bit bigger, so you can see. So yeah, so hello and welcome it wrote here. So this is actually what we call a string. Like it's a sequence of characters. So we can have a character in Java. We can define a character like A. So we can say character A equals A. I could also call it something. Doesn't matter what I call it. So this way I'm assigning a character A. So the string is no different from that. You can see we have these double quotes, and this is single quote. So with a single quote, it's a character, and with a double quote, it's a string. So if I make this into double quotes, I get an error because now it's not a character, so it doesn't work like that. Likewise, if I define a string, this is how I define a string. Something else. This is actually fine for a string. If I change this again into single quotes, it will also give me an error because a character and a string is not the same. We can convert back and forth. I'll look into that later, but for now, you should just know it's not the same. So a string is basically a sequence of these. So you can imagine it's like, let me just show you a small drawing here. So if we have some kind of string here, like, let's say we have the string hello, and we want this string to be put into different characters, we could split this up into the character H. We can split it up to the character E. We can split it up to L and O, right? So this would be our string put into characters. So basically a string is a bunch of characters that are grouped together. The way that these are grouped together is that they're grouped together kind of like an array. So that means that we have something that looks like this: H, E, L, L, O. And this also means that we have some indexes in the string. So this is going to be important later. The first character in a string is called 0. Let's just say index here. The second character here is called 1. Third character is called 2, 3, and 4. So they are kind of numbered from 0 to 4. And this can be used for different things. So when Java needs to store this in memory, you should know that a memory block in a computer, memory, or the RAM in the computer, is just like a huge array of spaces where we can store information in bits and bytes. So it needs to somehow know, where should I put the letters on the computer here? So for example, what Java does is that when I create a string, I write something like string s equals hello. Then Java needs to save that into this RAM up here. So what it does, it looks if there's a free space. Let's say that all of this stuff is already taken. So it needs to find somewhere where there's a free space and there's enough space for saving all of these characters. So what it kind of does is it looks, this is a simplified version of course, but still. What it does is it looks to find a place and it looks here, okay, here we have like 4 places where we can put the character, and then it puts them into here, like H, E, L, L, oh, sorry, 5. I can't count. So this way it puts the characters here and then it puts a reference to this place so that it can remember the address in the memory of this string here. So the address is going to be where the first letter in the string is, and then it's going to go to the end of the string and it's going to put some kind of marker here to make sure that it knows that this is the end of the string. But the cool thing in Java is we don't need to think too much about these things other than this is just what it does behind the scenes. It allocates this behind the scenes, puts it into memory so that every time that we write S on the screen, it knows that we're talking about the string here, and then we can work with that string. So this is the basics of it. So if we go and look here for the string, let's put it back into a string, and then let's move the hello and welcome up here, and instead I'm going to call this S, and then I'm just going to print out S here. So now I save the string into memory, and then the system out print line is going to reference that address and print that out. So it will be the same thing going on. I'm not using a here for anything. And it should do exactly the same thing. We can see it says hello and welcome. So that's all fine and good. Let's look at the next stuff here. So what is a string really? This is kind of what I covered here. It's a sequence of characters. And each of these characters is then saved as bytes or bits into memory, and we can then get them out again like this, and we can save them using this equal sign here. So we can save them to and from variables like that. So sometimes we want to work with these strings. We want to do different things to these strings. We need to, you know, add something or remove something from the string. So for this, we have some common methods that we use. So this is just, I looked this up. There are many web pages showing this. You can also go to the official Java documentation if you want. But I used W3 Schools because I actually think it's a pretty cool website all in all. And it has a good view of all of the methods here. There's a lot of methods that you can use with strings. So what I did to find this, I searched for Java string methods. This is actually what I searched in Google, and this is the first thing that came up. So it's pretty easy to find these kind of things here. But okay. So we have the methods here, we have what they do here, and then we have return type. That means that's what we get back when we run this command here or this method here. So if I say one of them, let's say I want to get the string as directly from memory as bytes, then I'll get a byte array like this. If I do something else, let's say something like matches here, where we can check if it matches some other string, then I get a Boolean saying it matches or it doesn't match, right? So there's a lot of different ones in here. Let's try to look at the ones that we tend to use a lot. So one of the methods that we use is the compare to method. I'm going to come back to that because that is going to be important down here. So I'll just make a note here that I want to talk about the compare to here. If we want to check if it contains something, I can even click here and see how to do that. We can say the name of the string dot contains and then the part here. So let's try to go back to the code, and then we can check if s contains some sequence of characters. We can just do that directly as a string. And let's see if it contains an O. And then run this code. And it says true. So, okay, it contains an O. What about Q? Shouldn't contain a Q. We can agree on that. Run the code. And it returns false. So it knows that it doesn't have a Q, and we can also do it for partial parts. So we can do, for example, welc. That's also contained in here. And so it says true, but let me show you something weird. So I say hello. And it says false. The reason for this is that it's case sensitive. So we need to make sure that we look at the case as well. So because I didn't use the capital H here, then it's actually not comparable. But if I do like this, it will return true. The common way of doing this, there are different ways. There are some advanced ways, but an easy way that we can actually check if it contains both capital and non-capitalized versions is that we can say, before we do contains, we can say s dot to lowercase, and then on the result of the to lowercase, we ask it if it contains hello. Let's try to do that. So what is going on here is that if I take this part of it, lowercase, we can see it converts the entire string up here to a lowercase version of it. So the capital H is no longer capital 1. And then when I do comparison, I'm careful to use only lowercase characters. This way, we get a case insensitive version. There's also some more advanced ways to do it, but this is really easy to read and understand, and this is the common way of doing that. So now we learned like 2 methods. We can make something lowercase, we can make something uppercase. There's a lot of stuff we can do with a string. Let me just try to look at some more. Another way of getting help, and this doesn't always work. If we have some errors in our code, it doesn't work, but we can just press dot to get what we can do on the string. And we can see that these methods are the same that we saw at W3 schools here. It's the same methods. Let's just go back here. Char at, copoint at, all of this stuff. You can also press Control Space here to or you can redo it like this, but if you press somewhere else and click here, Control Space, it pops back up. So we can see that the methods are here, but it's in different order. And the different order is just that IntelliJ kind of tries to be a bit intelligent here and try to show us the different things that it thinks is most important to us. So as we have the 2 lowercase part here, there's also 2 uppercase. Don't worry too much about this part here. We can do it without this localization options. We can also do other stuff. Let's find some cool stuff. So we can check the index of a specific character. So if I say the index of the character, not that one, let's say the L, for example. Oh, no, let's do O first. So if I say index of O, it will pop up with the index of that character, index number 4. So if you remember from before, I said that these are indexed. So if we see the first one would be 0, 1, 2, 3, 4. So O should be on the 5th place, like 1, 2, 3, 4, 5. Or if we count like a computer counts, like 0, 1, 2, 3, 4. So O is 4 and it says 4. So index of will return that. Another thing is that some letters are here twice, like E and L is here 3 times, both of them actually. So if I change it into an E, you can think about what would be like the expected result of that while we're waiting for it to show us. So it says 1. So as you probably already guessed, it just takes the first one. So if I have multiple ones, I get the index of the first one. So why would you want to have the index of something? Yeah, sometimes you want to find a specific part of a string and replace it with something else or something like that, right? So this is why you would like the index. So let's try to look at other cool things here. So there's also something here called replace. So when we do replace here, we can say we want to replace space and space with nothing. So let's see what that does. So I'm saying I want to replace this with nothing. So as you can see, it's like search and replace. If you tried that in some word editor or something like that, you can see it kind of removes that part of the... So pretty easy to use as well. Let's go further. Then there's also a lot of weird stuff that I won't go into, like code points and stuff. That's not really something people use a lot. I'll just go for the most like important ones. There's also one called replace all, because replace only replaces the first one. So if I do replace, I can take, for example, E, and I can replace that with some weird character like this one, right? Is there some error here? Yeah. So I replace E with this character here. And we can see now it replaces all the E's with that weird character. There's also something that is pretty nice to use. There's something called split. And when we do a split, we can ask it to split on different values. So split is something where we can take a string and put it into kind of smaller substrings. Often what we want to do, we want to split on something like a space. So what we're going to do is we're going up here, and then we're going to say string, array, split string, and I then want to split it. I need to say what I want to split on. So it needs some kind of letter or something. So I just put a space here, and then I can print out the split string here. Let's see what that looks like. So that looks a bit weird. So what is going on here? Yeah, so this split here, if I look at that, we can see that it actually returns something here like a string array. And when I try to print out the string array, it just says this is a string, an array of string, and it has this memory location here. This is the reference for it. So we can't really use that this way. We need some other things. So what can we do on the array? So we can check the length. We can do all kinds of stuff here. So let me just print out the length. Then we should be able to see, you know, at least if it has the correct length. Okay, so it says 3. So it means that it has split the string into 3 parts, like hello and welcome. And all the spaces, it kind of chews them up to, just removes them and then puts these 3 into the split. So here I kind of got ahead of myself and go into splitting and joining, but I just felt like it was the right time to do that. So the next thing we need to do is look at how can we loop over these things. So one thing we can do with strings is we can loop over them once they are split into an array. So I can create a for loop here. So if I type for I and then press tab, it automatically creates a loop for me. So it says for, and then it says integer I equals 0, while I is less than split string length. So this will loop from 0 to the length of the string minus 1. The reason it's minus 1 is that this is less than, so when I is less than the string it will run, but as soon as it's equal to the string it will not run. So why does it do like that? So if we look in here, we can see that when we have something here like hello, the index it starts from 0, goes to 1, 2, 3, 4. So the length of the string here is actually 5. If we count 1, 2, 3, 4, 5, the length of the string is 5. But we only want to go through, we want to go through 5 elements, but we want to start from 0. So this is why in this loop we have here, this is why we are looping from 0 to the length as long as I is less than the length. So it will be actually the length minus 1. So it will go from 0 to 4. So let me just show you that this is actually, and I'll do print ln, which will print a line. And I'll just start by printing out I, so we can see what the loop does. So the loop will run over, like run here 4 times. Sorry, 5 times. Okay, 3 times. I'm sorry. It's because I was thinking about the hello string I showed you before. So because this is split into 1, 2, and 3, of course it runs 3 times, but it will only run from 0 to 2. So this will be the 0th element, and this will be the first element, and this will be the second element, the welcome part here, because we split on this space here. So we can print out this, and we can also print out the split string of I, like this. So what this does is it takes the ith element of this string, split string, which is now an array, and then it prints that out to the screen. So we can see how the I corresponds, the index corresponds here. So we can see it says 0, hello, 1, and 2, welcome. So often we want to, if we have some kind of text input from a user, or things like sometimes we read from a text file, we want to split things up using commas, semicolons. We want to convert one thing to another. So splitting up strings and working with the split strings is like very important. So if you want to know more about loops, I think you should go and dive into that in further videos. But I think for this, I'm going back to the topic here. So now we know a string is just a sequence of characters. We know how to create strings, and we know some of the common string methods. There's, of course, a lot more methods. Sometimes we want to concatenate strings. So you're probably wondering, what is concatenation? So let's say that we have a string here, C, that we call cat, right? We have another string that we call dogs, right? And let's say that I want to print out, let me just move it to the end of this. So I'll keep the code we have here. Let's say I want to print out this, and then I want to print and then I want to print dogs. So how can I do that? Let's say I want to create a new string. Let's call this one con for concatenated. And I then want to concatenate these two. I'm not going to use the suggestion by IntelliJ here. So I can say C plus D. So it's very easy to join different strings together in Java. So system out println concat. And I think I'll just comment out this part here. Okay, so now it should say cat dogs. Let's try. Cat dogs. Okay, so what if I want to change it, to cats and dogs? I can simply just concatenate it further with a string that I put inline here, cats and this way it will say cats and dogs. So it's very easy in Java to concatenate strings or join strings together like this. So sometimes we also want to compare strings, right? So, but before we try to do string compares, I want to talk about something in Java called immutable. So the problem with strings in Java, or the problem with strings in general, is that it's a sequence of characters. So when Java needs to compare two strings, now let's make a couple of strings here. Let's just outcomment this part here for that. And then I'm going to make two strings. So I'm going to say string m equals hi, and make another string n equals hi. So now I created two strings. It looks like I created two strings. Let's try to do something. yeah, let's do what it says here. So this will check if m equals high. Let's also try to do something else. Let's say if m equals n, like this. So now we're checking if the string m is equal to n, and we're also doing m equals to n. Two different kinds of ways of checking if they are the same. And if we do this and we print that out, you will see that these are both true. But this is a trap, because this way you're not meant to compare these two. Let me show why it is like this. So if I print out m dot hashcode, I will see the unique code of that, and the n hashcode as well. Oh, sorry, I didn't mean the hash code. So let me explain a bit what I wanted to do. So I want to know if m and n are really the same in here. So there's a difference between having an object and having a string. So in Java, it handles this a bit like a weird way. So in Java, we have something that is called a string pool. And the string pool is a place where Java will save all of the strings to save resources. So when I create a string high, and I create another string called high, it's actually pointing to the same string. Let me show you. So here, where we have RAM, if I create another string in here, let's call this one string m, and I do exactly the same characters inside of this string, the Java pool will find out that this one is already in here, so it will just like piggyback it on here and point to the exact same address. So that means in reality in Java, when we have like two of these objects s and m, and if we have here our space of all objects, we will then have an object here called hello, and these will point to the same object. In Java, if we say s equals to m, this will check if this is the same object. The problem arises, and this is what I call the trap, the problem arises if I create a new string that is not created directly in the code, if I read it from a file, or I can also force it by writing string p equals new string. And then in here I can put hello. This will create a new string in memory as a new object because I have explicitly told it to be new. So it says new string hello. So now it will have another object in the pool, which is also called hello, or it's outside of the pool actually. So the p will then reference this object here. So if I write s equals p, the result of this will be false, because these two are not the same object. These are different from each other, so they are not equal to each other. So let me show you this in code. And the reason I wanted the hash code, this one won't work for it, but there's something called system identity hash code. So if I use system identity hash code, I can get somewhat of an idea of the object. So if I do this system identity hash code m and n, now if I print out this, we'll have the same result as before. Just a second. We can see true, and then we have the identity of these. So this is the where it points to in memory. So it points to this address here. So this is the same object. We know this. We can also say, we can think of it like this is the ID of the object in memory, right? This is the way it finds it in memory with this number here. So now we know that high and high are actually the same. But if I do string p and I say high for this one, of course this would also be the same object. Let me do the same thing. This is probably no surprise because I did it already with the others, but bear with me here. So if I run this now, it will have true, true, and again, the 3 similar numbers here, right? Oh, I didn't compare p yet. So let me try to change something. So if I change p here into, say, new string, this will force the string to be created outside of the pool. You could say this also seems weird. Why would you do that? But if you read from a file or you get it from somewhere else, this is what's going to happen. It's going to create a new string, and then this is going to be a trap. Because if I check if m is the same as p and m is the same as p like this, you can see it also warns here that I'm doing this comparison. I will get a surprising result. So we can see now that it checks here m equals p, but m equals p is false. So a lot of people fall into this trap here that you compare two strings using this comparison operator. So you should never use this operator for comparing strings. It's just something you should like get into your muscle memory or something like that, that when you're comparing strings, you should always use equals. Because in theory, what equals does is it checks that the characters inside of the string are the same, not that the object is the same. Because string is like a complex object. As we saw, it contains these different, all these, let me show you here. So it's actually this array here of different characters, so it's a more complex object than just comparing two numbers. In reality, I think, I'm not entirely certain, but probably just compares these two numbers and checks if these are the same because it's faster, because it already has this identity hash code built in, which is based on the location. So always use equals when you're creating new strings. That's like a pretty important thing to do. You can probably live for a long time with this without any problems, and then one day when you're reading from a file or getting something from somewhere else, then it all falls apart. So be very, very careful about that. Let me just find the list. So the string pool, where it kind of reuses strings, so it just references the same ones. You need to be, the compare to method. You can compare if two strings are larger than or smaller than each other. So compare to is like equals, but equals returns true or false, but compare to just tells us if one string, let's say that this is AI instead, so A is then coming before H in the alphabet, so this is why the compare to would then say that this is bigger than this, right? So that's just it. I don't know why I put it under immutable. Now that I think about it, it's not really relevant anyway, but this is what the compare to does. So yeah, string comparison. So lastly, let's go to the word immutable. So immutable is a term that we use in software when something is final, when something does not change its value. So when we create strings in Java, they can never be changed. So it looks a bit weird, you know, if I try, let me just comment out this part and then try something new. So if I create a string here and call it I, maybe S2, and then this is immutable, and then I want to do something like string S3 equals, and then I say S2 plus exclamation mark, right? And then we print out S3. So if we do something like this, it says this is immutable. But what if I say, you know, S2 here is equal to S2 plus this one here? Let's see, something is, oh yeah, I cannot state it twice. So I'm taking this one, S2, and I'm saying it's going to be itself plus this one. Let's see what's going on then. I told you I cannot change it, but here it is, changed anyway. So what is really going on here? So when I do this, this is immutable, it creates actually a new string and puts it here. But what happens here is that when I add this, this operation here will create an entirely new string. We can use our new find identity hash code here. So if I print out S2 here, and then I do exactly the same down here, we can see that it creates a new object, right? This number was the old object, this is the new object. So when we create a string, this is just a variable, right? We create the string here. When I add this one, it doesn't add it, it actually creates a new string where it takes this one first, adds this one, and returns the new string. We can see that if we do the concat, which does the same as the plus. If I look up concat here, we can see that it returns a string. So it does not change the original string. It never changes the original string. It simply just creates a new one. So every single thing we do with a string, we're going to create a new string. So this is a pretty important concept later on, but for now you should just know that is the case. When we change a string, we doesn't change the original string, we just create a new one. This is not the same for other things like integers and other kinds of variables, but it's true for strings. It has a lot of good benefits that we can use from this when we are doing immutables, something that I won't go into right now, but it's a nice feature that you'll like probably later on, because when it's immutable, you get some cool stuff with that. So yeah, so I took it in a bit of a different order than I originally thought, but I think this makes more sense. So we know what strings are, creating strings, common string methods, all of this stuff. So the last thing I think is important to know when we talk about strings is that how we're going to convert strings into other data types. So let me just write a program real fast, and I'll just skip because this video is getting long. Let me write a program that will take some input from the user and then try to calculate something. So I just magically created this code here. So this will read a line from the keyboard. There are other ways to do that if we want to read something a bit more, but this kind of returns the input whenever the user presses the enter button. So if I run this, it will take whatever I read and then just print it out to the screen. So in here, I can now write something like hello, and it prints out the same thing here, hello. So now it's saving whatever I'm typing into this input, but it's also waiting on executing the next line of code until I've pressed enter. I can, you know, keep writing lots and lots of stuff here. And when I press enter, it continues. So this is what the read line does. So what if I want to do something? Sometimes we don't want input only to be a string. let's say that I want to do something like age here. So let's say I want to calculate age from months old, something like that. And then I'll write something to the user. Something like, what is your age in months? Pretty weird, I know. So what I want to do now is I want to get the months old converted somehow. So I'm going to say months old. So let's try to just run this. So if I write something like 80, it will just say 80. So what if I want to calculate the amount of months that I'm old by, you know, dividing this by 12? This should print out the amount of months I am. But then it says you cannot divide a string by 12. Java cannot figure that out. It's pretty, it does understand. If I do plus, it knows about that because strings can be concatenated. So it will just, you know, if I do this and I type in 80 once more, it will just put it together like two strings. So it will convert this into a string and add them together automatically. But I want to divide by 12. So how can I do that? So first I need to convert this into some kind of number. And the way that I can do that is if I know what I want. Let's say I know this is like an integer. So I can say integer, pass integer, and then the months, right? So now I'm going to pass it into an integer and divide it by 12. Let's see what happens. So let's just do something easy like 12. It says 1. Nice. But what if I do 13? It also says 1. Okay, so that works pretty nice. So what if I'm very close to 24? Like 2 years old? Oh, sorry, that was pretty stupid. Okay, so I'll try again. I'll put 24 down here. That's what I wanted. 23. Whoop. Made a mistake. I think I ran it twice, so let me just wait for a second. Okay, so now I put 23 here, and it says 1. So it works perfectly. So you might also imagine or wonder why does it just, you know about that? I put 23, but let's say if I put 6 to this, like 18. Sorry, now I'm doing it again. 18, it should be 1.5, right? 18 months is 1.5 years, but it still just prints 1, and it works fine like this. So that is because when we have two integers here, this one is an integer, this one is an integer, is basically whatever is after the dot. So if it is 1.5, it just takes away this part automatically, and that just works for this case, right? Sometimes we don't want it to do that, so we can use some other kind of value. If I change this part into a double, of course I can't pass an int, but I can pass a double. It's just a type, and then we can change it. So if I do 18 now, it will say 1.5. So this way now it knows that. Another way we can do it is, even though this first part we try to pass this as an integer, we can also put a D here, or for double, or an F for float, so that it knows that this part is actually a double. Let's try. So again, I do 18, it says 1.5, or I can do something maybe a bit more intuitive. I can put the dot here, then it will automatically know that this is a float or a double, some kind of floating point number. So that was just a small detail. So sometimes if we want to convert strings into integers, we can do that. The other way is a lot easier, because if I say something like string number equals 18, then of course we cannot do that. But if I want to make this into a string, I can just put quotes around it. If I got it from an integer, I can't do that. Let's say int num equals 19, doesn't matter. And then what do I do if I want to change num here? So I could do, now I cannot do anything with an integer because, so I can say string, sorry, value of, and then the number, which is kind of like one way of doing it. Oh, I forgot to print it. So it says 19 now, so it works like that. I think there is a small hacky way of doing it, because we can actually just write something like this. So what happens here is that we have the string, which is this one, and we use the concatenation. And in Java, when we concatenate a string with a number, it just puts them together. And because this is an empty string, I just get 19. And I actually see this used a lot in the wild. This is probably the most normal way of doing it. The value of is not used too much. This is pretty fine way of doing it. No problem in doing it this way. Okay, so that is it for now from me with all of this string stuff. I hope the video didn't get too long. I'll try to put in some different points in here so that it's easier to see. Thank you for watching, and see you around.